Hey there, before we dive into gRPC, let's understand what is a local procedure. A local procedure call is a function call within a process to execute some code. Basically, a local computer which has multiple targets or modules within it. Here you can see there is one CRM system and the other is credit engine. When there is a lead request from client, then CRM process the data received and communicates with credit engine to get the credit eligibility. This communication is done through a function call which we can say is local procedure call. In remote procedure call, we instead of calling a function on your local program or local computer, we call the function on a different process, or a different computer. Here, since there are two separate server or computers or client and server, only function call won't work. After taking the arguments from the function, we have to marshal or stream them into sequence of bits. On the server side, the bit are then converted back to arguments, execute the logic and get the result. This result is again serialized and sent back to the client. Remote procedure call is better and there are several reasons. First benefit is scaling. We can add many more computers to send and handle requests at both ends. The second is security, as we have control over the server and we can decide which software runs on server, how people access it. Since RPCs are characterized by the serialization format used, I can write the server in Go language and still have clients in Python language. Stubs and interface definition. If CRM want to call getCreditReport function from credit engine, how should that work? Consider CRM is written in Java and credit engine is written in Golang. Essentially, the conversion of request and response, which is understood by both CRM and credit engine RPC runtime respectively, is done by Stubs. At both ends they have RPC runtime. At compile time, Stubs use interface description language to define client and server interfaces. These request and response objects are encoded and serialized, then converted to network call by the RPC runtime. These request and response are sent over the layer 3 communication protocol. This could be TCP or UDP. RPC can also happen over HTTP protocol. Every single RPC implementation gives you a way to define interface definition. We define the objects or rather types in this interface. One of the most commonly used interface definition implementation is gRPC. gRPC is the most popular implementation of RPC. It uses Proto format for interface definition. It is called a Proto file. So the function get_credit_report which CRM want to invoke on credit engine, its definition will be declared in Proto file. The stub generated using the Proto file is then encoded by gRPC and sent to the protocol buffers. The protocol buffer serializes the stub into binary wire. The gRPC then sends this binary data over TCP protocol. gRPC uses HTTP2 as its transport protocol. The same process works at the server side while accepting the request and sending the response from server. The protocol buffers are almost 4 to 5 times faster than JSON, which is why it is becoming a popular choice for RPC implementation. At Netflix, they use gRPC for the purpose of backend to backend communication. Netflix says, some response fields can be expensive to compute, some fields can require remote calls to other services. Remote calls are never free. They impose extra latency, increase probability of an error, and consume network bandwidth. How can we understand which fields the caller doesn't need to be supplied in the response, so we can avoid making unnecessary computations and remove calls? This is where Netflix came up with field mask. Let's say we want to get production information for a particular movie using the getProduction API. While a production has many fields, some of these fields are returned from other services such as schedule from the schedule service, or scripts from the script service. The production service will make RPCs to schedule and script services every time getProduction is called, even if clients ignore the schedule and scripts fields in the response. Requesting a large number of fields can make the response payload massive. In this example, if the caller only needs production title and production format, the production service can avoid making remote calls to schedule and script services. Using field mask, we can get only those fields which are required. If a consumer is only interested in production titles and format, they can set a field mask with paths, title, and format.
Hi, hope you liked the gRPC session. In our upcoming sessions we will be soon displaying gRPC implementation. Stay tuned and do like and subscribe.